In this video, we'll be talking about angle relationships. So we'll start with some that might look a little more familiar: supplementary and complementary. So supplementary is two angles that add up to 180 degrees. So for example, let's say we've got this angle here that we know is 100 degrees. And if I told you that it's supplementary with this unknown angle, well, you could use the fact that they're supplementary to find this mystery angle, because you know they have to add up to 180. So 100 plus what is 180? Well, 80, right? So using that relationship of supplementary can help us solve for missing angles, because we know what the two angles have to add up to. Same idea applies with complementary. So complementary is two angles that add up to 90 degrees. So I always tell my students, if you give me a compliment, you're probably right, because remember, a 90-degree angle is a right angle. Okay, so often what you'll see, the kind of diagram you'll see with these is that right angle that's split into two angles. So you've got this ray that's kind of cutting through the middle of that right angle. So then we would say that this angle here, we'll call this angle 1, and this angle here down here, and say angle 2, those are complementary, because when you bring them together, they make 90 degrees. That said, they don't have to be right next to each other like that. We could also have two angles that are completely separate. We could have a 40-degree angle and a 50-degree angle, and boom, those are complementary because they add up to each other. One important comment on complementary: sometimes people get confused and they start thinking that a right angle all by itself is a complementary angle, and that's not possible. You can't have a single complementary angle. You've got to have two angles adding up to 90. So one 90-degree angle by itself it's just a right angle. Okay, so moving on, we have adjacent. This is a vocabulary word that describes two angles that are right next to each other. So I'll just do this in purple here. If I have two angles that are right next to each other, we would say that they're adjacent. So actually, in this last example, these were adjacent angles as well, because they're right up next to each other. So technically, we would say they share a vertex and a common side, and they don't overlap. But really, you just want to think adjacent means next to each other. All right, so next, we have and by the way, these can be any size. They don't have to be supplementary. They don't have to be complementary, right? These are just two random angles I drew. Now, we do have a special kind of adjacent angles, and that's called a linear pair. So we get a linear pair when two adjacent angles that come together like this actually create a line. So you see that word linear, that makes us think of the word line, right? So if you have a straight line that's basically kind of split up by this ray into two side-by-side angles, well, that's a linear pair. So they are adjacent angles, and they are supplementary, because if you think about it, a straight line is 180 degrees. If we go around this curve, we're going halfway around the circle. So a linear pair is adjacent and supplementary. So once again, if I knew that, say, this smaller angle was, 75 degrees, I could solve for the bigger angle by subtracting from 180. So in this case, that would be 180 minus 75, and that gives me 105 degrees. So that's how I would find that missing angle in a linear pair. All right, so let's keep on moving. Next, we have a really important word, which is vertical angles. So vertical angles, the word vertical, of course, we've heard of horizontal lines and vertical lines. And honestly, that meaning of the word vertical has nothing to do with vertical angles. So I want you to try to just kind of get rid of that thought in your mind and really just think of this word as meaning something specific in geometry that's totally different from horizontal and vertical. Okay, vertical angles are formed by intersecting lines. So if I have two lines, straight lines that cross, they make sort of this X shape. And within that X, we can see that there's 4 different angles. 1, 2, 3, and 4. So vertical angles are the 2 angles in this sort of a diagram that are directly opposite each other. So for example, angle 1 and angle 3. Those are vertical angles because they are directly opposite each other. One way of thinking about it is they only touch at the vertex. So here, angle 1 comes together at this point, and angle 3 comes in at this point. So those 2 angles, 1 and 3, only touch at that center vertex. So that can help you too. But again, you need that intersecting lines diagram first in order to identify those vertical angles. So we would say angle 1 and 3. And then we can also likewise say angle 2 and angle 4 because those 2 angles are also directly opposite each other. And angle 4. All right, and the key thing when it comes to vertical angles, like this is super, super helpful and important, is that vertical angles are always congruent. And this will be more and more helpful as you get more into geometry and you kind of see, you end up working with more angles. But so like let's say that angle 1 is 65 degrees. Well, then we automatically know that angle 3 is also going to be 65 degrees. Now here's a kind of an interesting thing is with these intersecting lines, if you know one of them, let's say it's 65 degrees, that actually can tell you all 4 of the angles in that diagram. So we know automatically that the opposite angle is 65, but then if you think about looking just along one of these lines, look at this ray that comes out, and if you just look at what's in orange and sort of cover up all the rest of this, we have a linear pair. We have 65 and another larger angle that come together to form a line. So we can also find this larger obtuse angle by just subtracting from 180. So this guy would have to equal 115 degrees. And then if we bring the rest of that diagram back in, we knew that this one was 65, and now this 115 is vertical with this angle, so that one is also 115. So if you have that X shape and you know one of the angles, just know you can use these angle relationships to find the other 3. All right, finally, we have one more thing to talk about, and that is angle relationships and algebra. So now, the only difference is that instead of just working with numbers and saying, what's this missing angle? Now every angle has some sort of an algebra expression inside of it that represents that angle. So you really want to start by just looking at the relationship. How are these 2 angles related to each other? So I have this angle in blue represented by the 5x minus 13, and I have this angle in pink represented by 3x plus 7. Well, what do you know about the blue and pink angles? Well, those are vertical angles, and we know that vertical angles are always equal. They're always congruent. So we can take this 3x plus 7, which represents one of the angles, and make that equal to the 5x plus minus 13. 5x minus 13. And this is an equation that represents what we see going on in the diagram. So you can just take this angle and this angle, look at what is the relationship going on. If they're equal, then just set those 2 things equal to each other. Now that's a little different from this linear pair. We know that these 2 angles aren't equal to each other. This one is acute, this one is obtuse. They're definitely different. So we can't do the same kind of equation this time. So think about what do we see in this diagram? Well, we can see that they're a linear pair, which means they're supplementary. So these angles have to add up to 180. So we're going to do the same kind of thing setting up the equation, but this time we'll have 35x plus 2, and we'll add that to the 60x minus 12, and we'll make those two things added up equal 180. So there's different kinds of equations that we can write in geometry. Sometimes we're going to be saying this thing equals this thing, and other times your equation is going to be this thing plus this thing equals some total. In this case, the total is 180. In other cases, maybe your total would be 90 if they're complementary. It just depends on what you see in the diagram. That determines the kind of equation that you set up.